Hey, we're going to look at graphing acceleration and looking at a couple of practice problems, calculating slope, all that good stuff. So let's get started. When we are graphing acceleration, there are two different kinds of graphs that we can look at. So the one that you should be familiar with is a velocity versus time graph. So here on the right hand side is our velocity versus time graph. And as you can see, this line is a straight line, meaning it's some sort of constant increase in velocity. Our other type of graph is our distance versus time graph. On our distance versus time graph, acceleration is always going to be represented by some sort of curved line. It could curve this way, it could curve this way, but no matter what, it is a curved line that represents acceleration. All right, so you can use a graph to calculate acceleration. So we already have a formula whenever you have some sort of scenario and you know the initial and the final speed, but also you can calculate acceleration looking at a graph. So the slope of a velocity versus time graph, and this is a velocity versus time graph. The slope of this graph is acceleration. So the slope is the acceleration of a velocity versus time graph. So this graph to the right shows a constant velocity. So pay close attention, you have this nice horizontal line here, meaning whatever this object is, it's traveling at a constant 5 meters per second the entire time. So constant speed, constant velocity. Since it's having a constant velocity and we have no mention of a directional change, there is zero acceleration on this graph. So no slope, no acceleration. All right, this top graph, another velocity versus time graph. And as you can see, we have a positive slope. This graph shows a direct relationship with increasing velocity because as time goes on, the velocity is increasing. We go from 0 to 1 to 2 to 3 to 4, 5, 6. We are increasing. So we are increasing velocity over time. That is a positive acceleration. All right, let's look at this bottom graph. So this graph shows an inverse relationship because on this velocity versus time graph, we now have a decrease in velocity. So as time goes on, we are decreasing in our velocity. So we're going from 6 to 5 to 4, 3, 2, 1. So we are indeed decreasing in velocity. This is a negative acceleration. So also let me point out on this graph, negative acceleration can happen with a positive velocity. These are all positive velocities, all positive numbers, but we are decreasing in speed, so it is a negative acceleration. All right, so now let's look at the speed versus time graph, or a velocity versus time graph. And so far, just looking at the graph, you can see that we start at 0, we go to 2, 4, 6, 8, 10, 12. So our speed is increasing, right? So number one, if the speed is increasing with time, what kind of acceleration do we have? Is it positive or is it negative? Right, it's positive. Okay, also, this data on this graph created a straight line because there was a constant pattern. So the line is straight. That means that the acceleration is constant. For every second, we're increasing by the same 2 meters per second for the speed. We're adding 2 meters per second for every second. All right, another graph. So in speed versus time graphs, acceleration is equal to the slope, right? And we know that slope is the rise over the run. So slope. Slope is equal to the acceleration. So for this one, it's asking what is the acceleration of the object between time 3 seconds and 5 seconds. So I always like to draw my graphs. When it's asking for specific times, I like to draw all my graphs so I know exactly which part of that line that I'm looking at. So from 3 to 5. So here to here. We are only looking at this segment of the line. So we need to find our rise and our run, right? So our rise, it looks like we go up 4 meters per second. Now keep in mind, sure, yeah, it's 2 lines going up, right? 1, 2. However, each line is worth 2, 4, 6, 8, 2 points. So if we're talking 2 lines, that's 2 times 2, 4. Or you can just look over at your y-axis and note that we started at a speed of 6 and we went up to a speed of 10. 10 minus 6 is 4. So either way, our rise is 4 meters per second. All right, then we're looking at our run. Well, our run is based on our x-axis. So from 3 to 5, that is 2 seconds. So if we're doing rise over our run, we're going to need to do 4 divided by 2. So rise over run, you just plug in. So our rise was 4, divided by our run was 2, and then we're going to end up with 2 meters per second squared. Notice how, again, our units for acceleration is squared. All right, so just a quick review, distance versus time graphs. Increasing speed is acceleration, decreasing speed is acceleration. We don't really use deceleration. It's either positive acceleration or it's negative acceleration. So looking at these curved lines, let's look at the graph on the left first. When we say increasing speed, it's kind of hard to tell with a curved line, right? But breaking into segments. So at first, you have this very shallow slope. So it seems like the object's going kind of slow, right? But then the slope gets really steep. So steep means that it's going fast. If we're going from slow to fast, yes, that is increasing. Let's look at the graph on the right. So break it into parts. At first, it has a very steep slope. It's going straight up. So at first, the object's moving very fast. Then, all of a sudden, it's much shallower. So it's slower. So if we're going from fast to slow, that is decreasing speed. All right, and if we're talking about changing speed in the positive direction, so now we're looking at speed graphs, so speed versus time graphs, that would be a positive acceleration. So let me say that again. We are changing speed, so acceleration because the speed is changing, and it is in the positive direction. Positive direction, notice how we have this positive slope, and to prove it, we are going from 0, 10, 20, 30, 40, and then all the way up to 50. We're increasing our speed, so it's changing, and it's in the positive direction. So we're increasing speed, and it's in the positive direction, so it's positive acceleration. All right, now if we are changing speed, but this time it's in the negative direction, and remember we're still looking at our speed versus time graphs, that is now a negative acceleration. So we are changing speed, we are decreasing speed. Notice how we're starting at about 90, we're going to all the way down to 0. So we are decreasing speed, and we're going toward the negative direction. So the pattern here is that on our speed versus time graphs, if the slope is positive and the speed is increasing, you have a positive acceleration. All right, there's other videos more along the lines of positive and negative acceleration, so be sure to check those out if you are still a little confused. But for now, I will catch you later. Thanks for watching. Comment if you have any questions.